This meeting is being recorded.
Hey, so hello, my name is Kreshshale. This is my Lab 1 Part A demonstration for the subject Computer Organization and Architecture. So now I'll show the debugging process for the assembly program titled Add and Subtract. Step 1 is we have to open the program. Here is my program for Part A. So it adds and subtract 32 bits integer directly using the EAX register and save the result into a variable called total. Two is we have to set a breakpoint. Now I will set a breakpoint at the first line inside the main proc, which is MOVEAX 123400H. Okay, so step 3 is I'll start the debugging now by pressing the debugging or F5. Okay, done. Okay, so next is step 4. We have to open the required windows. Okay, so for this lab, I will open the following windows to observe the program execution. First of all, watch. Okay, so next is autos. Okay, so third one is memory. So fourth is register. Okay, so the last one is disassembly. Okay, so the step 5 is add variable to watch windows. I'll add the variable total into the watch window to monitor its value. Okay, so step 6 is step-by-step execution. Now I will show step 2 the program using the F10 and explain what it happens. Okay, move EAX 123400H. Okay, so next is add EAX 567800H. Okay, so next is sub EAX 77700H. Now we move to move total EAX. The final result is stored into the total now. Okay, so step 7 is we have to observe the changes. You can see the EAX and the total have updated accordingly in the register and watch windows. Okay, so as a conclusion, I conclude my debugging demonstration for Lab 1 Part A.
Now is for the lab 1B question 1B, and Firstly, I will build the project first, and then I will add the breakpoint at the line 18 in the main procedure, and then I will start debug. I will try with the start without debugging first to make sure that the program is functioning. Okay, and then I will start debug. Same, I will open the windows of memory, disassembly, register, watch, and also autos. And then in the watch one, I will set the value of I will set to find the final value, and I will set to search this address at here, and then I will start my debugging now. At here, this will show that the value at address of this one now. And then first I key in F10 to execute the code of the line 18, which is set the value 1 into the EAX register. And then I will press F10 again to add the value 2 into the EAX register, which is originally it will be the 10,000 hexadecimal, and then now will be the we'll add the 40,000 hexadecimal into the EAX, which now will become 50,000. Now the value will be 50,000 in the EAX register. And next we will subtract the value 3 into the EAX register with pressing the F10. And then it will become 30,000 hexadecimal after subtract the 20,000 hexadecimal. And then lastly, I will press the F10 to store the final value of the EAX into the final value decimal. And then it will comes out with the final answer of 30,000 hexadecimal. And then I will input F10 again to display the value in the register. And then F10 again to exit the debugging. Then it will show my final output, which EAX is equals to the 30000 hexadecimal here. So that's all from me. We'll proceed with 1C.
So now this is the part C of lab 1. So I will first build Okay, and then I will first start without debugging to see whether it works. So it works. So the value is 3000 here. Okay, now we're gonna do the debugging step by step. Okay, but before that, we need to choose the breakpoint, which is here, line 15. Okay, now we will start debugging. Okay, so we need to choose the 5 windows we need to display. The first one is memory 1. Okay, it's here. Okay, and then the next will be registers. Let's see here. Windows. Okay, disassembly. It's available here. And then auto here. And lastly, watch 1. Okay, so now we're going to debug by pressing F10. So now it started with 1000 hexadecimal. So it has updated here. And now we have added 4000 hexadecimal. So the total will be 5000 hexadecimal. Now we subtracted 2000 hexadecimal. So it becomes 3000 hexadecimal here. And then lastly, we're going to store this result in final value W. And then I'm going to, okay, so the final value, the value has stored in the final value W. So this is the decimal value of the number we stored. So in hexadecimal is 3000. So now we're going to call dump press. Okay. So to see that, so it should be here. So now, oh sorry. Okay. Okay. So now the next part. Okay, we're going to do the same. Start with 1000. Add 4000 hexadecimal. Then subtract 2000 from it. And then move to final value B. So here is it. This is 8 bits. And then all dump rights. Okay. And then let's see. Yeah. So then exit. So yeah, so this is so lab C is completed. Can stop.